Okay, I'm going to go through how to create a regression of fit using a graphing calculator. Okay. All right, we have a set of data that we need to input into a calculator, so I'm just going to make up quickly a set of data. 1, 2, 3, 4. I'm going to use a set of data that we are familiar with from last year. I'm going to use a sequence of 2, 6, 18, 54. Okay, so term 1 I'm going to call 2, term 2, 6, 18, 54. Remember that as being a geometric sequence from last year, where the next term is found by multiplying by 3. Geometrics, as you remember them, had common ratios. When you take the second term and divide by the first, it equals the third divided by the second. Okay, so for this one, 6 over 2 equals 18 over 6. Notice that the common ratio is 3, and we said it was because of this multiplying by 3 pattern. Okay, so geometric problems, as we also remember, have a specific set of rules. Geometric rule we stated last year was a rule such as t sub n equals the first term times that common ratio to the exponent of n minus 1. So we can come up with a rule for that sequence using that rule. T sub n equals the first term to common ratio of 3 to the n minus 1. That rule can be used to describe that pattern. But the calculator can also be used to establish an equation, which is a regression, for a set of data such as that as well. So that's what we're going to show you today. So on your graphing calculator, we need to input those values. Notice I have the key press history to my side. So for people like you, Stephanie and Amber, who don't play much video games, you might want to watch that. So press second, press stat actually. Let me clear that. Press stat and press stat, edit, enter. Okay, so what we're going to do is now input those numbers into our table. So list 1, put in 1, 2, 3, 4, 5. List 2, put in 2, 6, 18, 54, 162. Okay, so I'll just wait a minute for you to do that. Okay, so now that those numbers are input, we go to second stat plot. We want to graph that scatter plot. So notice my plot 1 is off. I need to turn it on. So press enter on, highlight on, and press enter. Notice the scatter plot has been selected. I have the X list is list 1, the Y list is list 2. So everything is where I need it. So now I go to the zoom key, press zoom, and scroll down to the command of statistic. Zoom statistic number 9, press enter, and you'll see that scatter plot graphed. Okay, so as we said before, we can use a calculator to come up with the equation for that set of data. And that is definitely a geometric sequence as we described before. So to come up with the equation, press statistic once again, statistic. On top, climb over to calculate. And notice that below, starting with line 4, are all sorts of possible equations. We have linear equations, quadratics, cubics, quartics. None of those would best fit the model that we've drawn, though. As we proved before, an exponential, which is another way of saying geometric equation, would be the best. So pick exponential, press enter, and it's waiting for you to press enter again. And now we have a set of parameters for A and B with variable x. So we'll want to write that equation down. with our data. So that's y equals a times b to the x. A is 2/3 and b is 3. Losing my voice here. Why is it? Y is equal to a is 2/3 and b is 3. So just a quick check to see if that equation models that data perfectly. Mental math. 3 to the 1 is 3. 3 times 2/3 is definitely 2. Works for the first point. The second point, x of 2. 3 squared is 9. 9 times 2 is 18. 18 divided by 3 is 6. So it definitely seems to work. Now that we're satisfied that it works, let's actually graph it over top of the scatter plot. Press y equals, and let's input that equation. So y equals, I like to put fractions in brackets, so it's 2/3 times 3 to the exponent x, and press graph. And lo and behold, the graph covers perfectly the set of data that we put in. Therefore, we have a perfect geometric sequence. Goodbye.